Okay, let's go ahead and get started. Well, welcome everybody to the latest edition of the Power Up webinar series. Tonight we're going to talk about lactate threshold and some of the important aspects of lactate threshold and how it integrates and can guide your training. So let's first talk about threshold. So what exactly is threshold? Basically, what threshold is the power, pace, or heart rate that an athlete would average in a 1 hour all-out time trial with fresh legs. And that's a very important component. It's your threshold numbers assume that you could maintain this effort, but only if you have fresh legs. Your lactate threshold, your anaerobic threshold, your functional threshold, those are all terms that people throw about, and they're not all the same. And hopefully tonight Ashley and myself can add some clarity to those different terms and how they can be used and how they're different. So Ashley, you want to tell folks what lactate is?
Yeah, so for those of you who know me pretty well, this is probably a very passionate topic for me. And so yeah, so we'll start basically with just what is lactate. But before we get a little bit deeper into that, we kind of need to just do a quick overview of basic bioenergetics. And so kind of talk about how lactate is even produced. And so it's produced through a process called glycolysis, or like fast glycolysis. If you can kind of see on the screen, there's all these arrows and everything. And basically glycolysis is the breakdown of glycogen to produce ATP. And so with this, we start with blood glucose. It goes through this whole entire process. Down at the bottom, you'll see the word pyruvate. And from there, if oxygen is present within the body, so if we're doing just low, steady state, zone 1 endurance type ride, we have enough oxygen in the system, and then that's going to go into what's called the Krebs cycle to produce more ATP and give us energy to be able to keep on going. So when we get a little bit higher intensity and there's not enough oxygen present within the muscle, then the pyruvate is going to be converted into lactate. And so that right there is kind of a basic process of that. If we want to go to the next slide. And then, so from there, so lactate is just a byproduct of fast or anaerobic glycolysis. Once the body has produced lactate, it is then transported to the liver and then converted back into glycogen via the Cori cycle, and then it's sent back into the muscle to give us more glycogen ATP. And then other muscles such as like the heart and then also the brain can use lactate to function as well. Some common misconceptions that are associated with lactate. Lactate does not cause fatigue or muscle soreness from exercise. And this is probably one of my biggest pet peeves, is that lactate is not the burning sensation that you will feel during exercise. This is actually the hydrogen ions are the culprit. And then a little bullet point in the bottom is that the hydrogen ions are present because the splitting of ATP, which is done primarily outside of the mitochondria within the muscle. And then this right here, the splitting of the ATP is what produces the hydrogen ions, which gives us that burning sensation or that acid. So lactate is not the reason why you fatigue, is basically the point of that. So if it's not the reason why we fatigue, so why do we even measure it? Lactate is a very easy, simple way, fairly accessible for most people to see what's happening within the body that, on a physiological level during exercise. So like I said, high levels of lactate do not correlate with the onset of fatigue, or high levels of lactate do correlate with the onset of fatigue, but does not cause it. So correlation does not equal causation type of thing. It's a lot easier to measure the lactate within the blood than trying to get the hydrogen ions or the other byproducts within a muscle. I'm sure most people do not enjoy taking muscle samples from the leg. And then from this, we are able to get an idea of what energy systems are primarily being using during a certain workload for yourself. And then let's see. Okay, and so from a lactate test, we can get two readings, two numbers. We have the aerobic lactate threshold, LT1, or the anaerobic lactate threshold, which is LT2. So aerobic is the intensity at which the concentration of lactate begins to increase. So this is your primarily aerobic metabolism. You want to think about like an endurance type pace. When we get into higher intensities, we will reach what's called an anaerobic lactate threshold, LT2. Another term is called the onset of blood lactate accumulation. People call it OBLA or OBLA, whatever you want to call it. And basically, it's just the intensity where the production of lactate exceeds the uptake. And you just kind of want to think about it as a traffic jam. You have all of this lactate that's trying to get to the liver to convert back into glycogen, and your body can only do that so quickly. And then see, so the first one will be at the first little slope, and we will look at that in the next slide. And then the second, the LT2, will be the second significant increase in the slope. And so from here, we can kind of see around 140 watts. This is our aerobic threshold, so LT1. Once we get up to that 180, we will start getting to that LT2 or anaerobic. And this is actually a really nice graph because you can clearly see that. Not everyone is this pretty.
Not even close.
Yeah.
So I'll go back a slide so you can.
Okay, yeah. And so this LT2, it generally occurs around like 85% of max heart rate or 75% of your VO2 max. Okay, so we'll talk about like the LT test. And so it's just your basic graded exercise test where at every stage, the person administering the test will record and monitor your heart rate, RPE, your ratings of perceived exertion, and then the blood lactate. Just note that the most common place for most people is the finger to take the blood sample, but there are people that also use the ear as well. Not quite sure how many people like to get stuck in the ear. And so once the test is completed, your information will be graphed, which we saw on the previous slide. And then the data points are plotted, and your coach or the person administering the test will be able to interpret the information to determine your LT1 and your LT2 points.
Show what happened there.
There we go. And so this right here is just a quick little video to kind of show you the process that we do at Power Up. We do should be able to play it.
Do you know if it's embedded in the? We're gonna find out, aren't we? Something's happening. It's loading. Something.
I have it on my screen if you want to transfer.
It's loading. Can you guys see this? The black screen now?
Not yet.
So far, I only see Ashley and her next victim.
While we
There
wait
we go.
for it to load.
Can you see that now?
No.
You
You
need to
guys
share
have-
another window.
I do, definitely. Okay, let me pull up another window. I got windows everywhere. Okay, here we go. Stop that share. And share a new window. Here we go. Okay, can you see it now?
Yes.
Yes.
Okay, hopefully this speed will run, it'll run okay. Is there an audio to this, Ashley?
No.
Okay.
Wasn't sure everyone wanted to listen to the music John listens to.
Or the screaming.
It's trying. It's loading. Okay, what we've done. Sorry for the delay, folks.
There it goes.
It would be faster to do it on your screen, Ashley, to give you controls.
I have it pulled up on mine and it's already loaded.
Okay, let me try that. Let me.
Okay.
There you go. Now it's moving. Can you guys see it moving? See John pedaling?
Yeah.
Yep, slowly
Yep.
pedaling.
And so, yeah, so with this, take a little cotton swab with alcohol, clean off the finger, and then dry it off. And then we'll take the blood sample, make sure he has a good open spot on the finger. And then we'll take the lactate analyzer with the strip, take a little blood sample. So it's really easy, really quick. The test itself is a 3-minute graded test. Every 3 minutes, the watts will increase, and right before the next step, we'll record the RPE, the heart rate, RPM, and then the blood lactate. I don't know, I'm pretty sure most places, at least that I've been familiar with doing LT tests, are always like a 3-minute grade, at least for cycling wise. And I'm not quite sure. I'm assuming that's probably like the gold standard, both in undergrad and grad school. That's the protocols that we used. we can go back. Okay, there we go. The testing. Okay, so for the testing, what you'll need is a bike, trainer. If you're doing it while running, treadmill, probably do like on the rower, whatever endurance sport you're doing. You'll need that lactate analyzer, which you can see on the screen. This is the one that we specifically use, along with the test strips, heart rate monitor, and then also it's not included in here, but like a smart trainer or cycle ergometer where you can adjust the wattages when needed. To prepare for the test, you need to make sure you get adequate sleep, good nutrition the days leading up, making sure you're hydrating a few days leading up as well, and then ideally no exercise 24 hours before the test. And the no exercise before 24 hours is just to ensure that the lactate levels in your body are at resting levels. And so lactate threshold. The test provides insights into what's happening within your body from a physiological stance. You're able to see which workloads you're primarily relying on which energy systems. And then depending on what your goal, what your discipline is, you'll be able to know exactly what type of training you need to focus more on to optimize your performance. The drawbacks of lactate threshold testing is it's not readily available for athletes, for all athletes, and then sometimes the results are hard to interpret. And so there is a little bit of confusion with that, especially if you have somebody who has a really horrible graph. It's definitely not always the easiest. And then so to kind of compare that to the functional threshold power test, FTP tests are another exercise tests that most cyclists and triathletes are familiar with. So these could be anywhere from like an 8-minute, I think it's generally 2 by 8 minute. You have a 20-minute FTP, or you can even just go all out and do an hour FTP. The 8-minute and 20 minutes are going to be an estimate of that 1 hour. And the goal of this is just to predict your threshold power so we can create training zones. It's easy to administer for athletes, and they can generally perform them by themselves. And it was developed as a field test to determine their threshold. The drawbacks of this is not everyone is good at testing. There is few athletes definitely have a lot of anxiety associated with these types of tests. Someone who has a very good anaerobic capacity can mask having a poor aerobic capacity. Jim and I, we were just talking about, there's a triathlete here. And Jim, if you want to kind of explain that.
Sure. I'm going to jump ahead here. So this is an individual who was training in the center, and he was truly a world-class triathlete. And as a junior, he actually won the world championships. And this is a test that we did on him. And he had a huge anaerobic engine. So because of that, in a 20-minute test, his numbers, his 20-minute power looks really, really good. So if you typically with a 20-minute test, you know, the rule of thumb is to knock 5% off that to determine an individual's threshold power. You can look at this graph and really concentrate on the blue line. And you can see that, I mean, the yellow line, the yellow vertical line is where we estimated his lactate threshold to be. His functional threshold was closer to 310 to 320, which is not unusual, particularly for individuals who have a very big anaerobic engine. But the thing that was really striking to us when we tested this young man was his LT1, or his aerobic threshold, was only 220 watts, which for a normal person might be pretty good, but for a world-class athlete, it's not very good. So when we were actually training him for the World Championships, the majority of his training was to improve his aerobic capacity as opposed to improving his anaerobic capacity. And in the absence of lactate threshold test, we would have been working off his functional threshold, and we would have been training him too hard to build his aerobic capacity.
And then the last little bit of the FTP is that, so FPT tests will always typically predict higher threshold numbers due to a psychological factor in the length of the test and correction factor. Most athletes are very strong-minded, and we can hurt a lot. And so just with that in mind is that an FTP test is always going to be to the right for I would say most athletes will be to the right. And so it's always going to be a bit higher than your LT test or your lactate threshold number.
And that holds true for, oh God, I don't know how many hundreds and hundreds of tests that we've done since we've opened the center, but that is pretty universal.
Yeah. And so yeah, so how to train with your lactate threshold results. You have a lot more accurate training zones. You're training the specific energy systems that you need. So you have like your anaerobic glycolysis, you have your aerobic glycolysis, you have all of that. And so to know which, or like your creatine phosphate system, which is like your really high intensities. And so being able to do an LT test, you can kind of see where we need to work, which the graph that we just talked about showed us that. You can assess your aerobic, anaerobic fitness with multiple tests throughout the year. You can see how training affects your fitness. So the ultimate goal is to shift the graph to the right, which means working longer, more efficiently at a given wattage.
And let's see, let's come back. So this series of graphs is a good example of what Ashley was talking about in regards to shifting the curve to the right. And once again, I pretty much ignore the red line, that's heart rate. That's another presentation and another discussion altogether. And let's focus on the blue line. So right here that you can see that, you know, his LT1 would probably, in looking at that graph, I would say it was probably a 200 watts. But he's getting incremental increases in lactate before that. But I would strike on him to strike the LT1 at 200 and his LT2 at 240. This was in the fall of 2017. And this was after he had taken probably a good 6 weeks off following his final race of the season. So this is 6 weeks later in the winter, and you can see how much flatter that blue curve is. And he's probably moved his LT1 in that curve probably out another 20 points. But even before that, if you go from 140 to 200, the curve is, there's not that incremental rise. So basically, if you look at that, what that is telling you is that from up to the point of 200 watts, he's burning almost exclusively fats. So he's not dipping into the glycogen stores in his muscles at all, which is really important because even the thinnest person out there has an unlimited supply of fats. It's when you start dipping into your glycogen stores that the clock starts ticking, and you only have a limited amount of glycogen stores in your muscles and liver to fuel exercise. So you want to preserve those as much as possible, particularly the longer event, the more critical that is. So same athlete in the early spring. And now, you know, the flat portion of the curve has gone out even further. You know, I would probably strike his LT1 there at somewhere between 220 and 240. So he's pushed out another 10 or 20 watts. He's pushed out the flat portion of his curve where he's burning almost exclusively fats out another 20 watts to 220 watts. And his LT2 or anaerobic threshold has moved out to about 260 or 270 watts. So this is the added information that a lactate threshold test provides that a functional threshold FTP test does not provide. An FTP test has its utility. I'm not suggesting that it does not have its utility, but it doesn't, as Ashley was saying earlier, it doesn't give us any insight into physiology and what fuels are being burnt at what power levels. Another interesting series of graphs is this series of graphs. So this was a woman who was a national champion on the bike. And this was in the winter of 2016. And you can see that she's not a very big woman. She probably weighs about 115. So this power profile is pretty impressive for a 115-pound, 120-pound woman. And her LT1 right now in the winter of 2016, she was in pretty good shape, was at 220. And up to that point in time, she's burning primarily fats. And she's got a very distinct, a very sort of classic graph, so it's pretty easy to determine her numbers. Her LT2 or her anaerobic threshold was at 260. So she was in pretty good shape in the winter, going into even before preseason. So this is the same woman at the end of her season in the fall. And the important thing to notice here is, first of all, LT1 actually dropped back 20 watts to 200, which you say, oh my God, you know, did she have a horrible season? It's like, no, she didn't have a horrible season. She won the national championship. But if you will look at the blue curve to the right of the yellow line, it's much flatter than it was, wrong way. It's much flatter than it was here. If you notice that, like from 200 to 280 or 260 to 280. And basically what that is showing you is in order to get in racing shape, she had to do more anaerobic work. And the result of doing more anaerobic work was twofold. First and foremost, and what she needed for racing was to flatten the curve right of her anaerobic threshold. But that comes at a cost. And the cost is she reduced her aerobic threshold. So this is a graphic representation as to why why somebody should not be training hard, like full on the gas doing intervals and things like that year round, because although intervals are needed at various points in the season, if you did them all year round, basically you would be sacrificing your aerobic capacity. So that's actually a pretty cool series of graphs. I think. Yeah, I think that's, did we have anything else, Ashley?
No, I think that was pretty much it.
Yeah.
Try to keep it fairly like basic and not go into too much depth.
So now we'd like to open it up to questions. Does anybody want to go over any of those graphs? Do they have any questions about FTP testing, lactate threshold testing?
What do you read off the heart rate though?
The heart rate, two things. The first thing is unlike an FTP test, a lactate threshold test also gives you your threshold heart rate. So that's what you read off there, just in terms of threshold. The other thing you're looking at is over time, as you get more fit, you start comparing the heart rate at different power levels. And as a person gets more fit, what you should see, everything else being equal, is you should see that their heart rate is beginning to drop at certainly sub-threshold power levels. Sometimes it drops above threshold, sometimes it doesn't drop above threshold, but certainly in sub-threshold, and what I mean by when I say threshold, I mean the anaerobic threshold, the yellow line in this case. The heart rate will drop at any given power level. Yes.
Hello. Question about AMP human and sodium bicarbonate and how that would impact, because their big thing is buffering lactic acid. So how does that play into your LT1 and LT2? Is it trying to push that LT2 further, or what is at play there? Sorry, if that's a question.
I mean, they're, Ashley, you want to take that one, or you want me to take that one?
Yeah, so I've actually had a very lengthy conversation with a person in exercise science who actually works with AMP human. And so first of all, sodium bicarbonate absolutely does work. Like drinking, whatnot. It just makes the whole thing like less acidic, so helps buffer out like the hydrogen ions. And that's what the sodium bicarbonate does. Well, so with AMP human, the same theory is there, but they're still using old terminology as far as like lactic acid and stuff. And so, and like I said, I've had a conversation with an exercise scientist that works with the human, and they're trying to get their marketing to go away from using those words, but that word and those thoughts are so embedded into being an athlete and like endurance performance. And so yeah, so the whole theory there is to make a less acidic environment. But it's more for like the hydrogen ions and not the lactic acid. If that
Well,
makes
that's exactly it. I noticed in the beginning of the presentation when you were talking about the lactic acid, and that's not the burning in the legs. That's actually
Yes. There's actually a really good article about like the whole like lactate and lactic acid like paradox type of thing. I can share that with people if you all want.
yeah, definitely.
Any other questions?
Hi, Jim and Ashley. Yeah, I have a question, Pablo here.
Yeah,
So with this, when you do the test, you have all the zones for training purposes. So what happens when you don't follow the training zones? Like you say, okay, this is a zone 3, zone 2, endurance, tempo, whatever. For whatever reason, you don't respect that. So and you go higher because you feel good. So what happens with that? Which is the drawback of going higher, or is good, is bad?
the drawback of going higher, whoops, is, nope, is this. If you spend too much time there, your aerobic capacity it deteriorates. So you see in this graph where, I wish you could see where I was pointing my pencil here, my little cursor. So right here at 220, this graph is almost dead flat all the way out to 220. Before it even start, before you start getting any rise. And now you're starting to get a rise at 200. So her actual LT1, which is her aerobic threshold, actually moved back 20 watts. So if you spend too much time above threshold, you're building your anaerobic engine, but it comes at the cost of your aerobic engine.
Jim, would you,
And I have to interject here that that threshold is a zone. Threshold true is not really one number. And if you ever want to test that theory, think about doing the same workout multiple times and think about some days that workout may feel like, let's say it's a sweet spot workout. Some days that workout feels like a 6. Some days that workout feels like a 6 out of 10. Some days it feels like a 5 out of 10. And some days it feels like a 7 out of 10. Same wattage. So, every science, everybody talks about threshold being this one magic number. It's a zone. And, and it's not black and white. It's not, to the left of that number, it's all aerobic, and to the right of that number, it's all anaerobic. It's gray. It just gets more black to the right and gets more white to the left.
Jim, this is Mike, would you also say that, a curve like this one, might be beneficial for somebody who's doing criteriums versus the earlier chart maybe being more beneficial for, let's say, a triathlete doing a half Ironman?
If these, I'll say a qualified yes. The reason I'm qualifying that is it depends on the seat, at what point in the year, training year they're at. If they're in their racing season, absolutely. Because in a half Ironman or anything half Ironman or longer, if you go anaerobic, you're going to bury yourself. You have to stay aerobic. So you want that blue line as flat as you can, as far as long as you can make it. To Mike's point, if you're a crit rider, somebody like this that had a profile like this, once they went above their threshold, they would be struggling. So they would, whereas somebody with a curve like that, they can bounce above their threshold, back down, above their threshold, back down, above their threshold, back down, and they would probably be fine. But this person is you want to build, in the off season and the preseason, you want to build this aerobic engine as big as you can get it before you start doing this. Yeah. Because if you don't do that first, then instead of dropping back, 20 watts, well, it would have never gotten up to 220 in order to drop back to 200. You may have only gotten your aerobic threshold up to maybe 200 or 180. And then you're just, suffering. I mean, you'll be anaerobic just sitting in a group. Any other questions? It's an interesting topic. It's fun to.
Is your lactate point LT1 the same over different distance? Biking, swimming, running, all those ones, is it the same or are they different?
It would be different. Just kind of like your heart rate is different when you're running versus when you're cycling or when you're swimming. Yeah, it would be, there's a number of reasons for it, not the least of which is all the muscle groups involved in like swimming versus cycling or running versus cycling. So that affects these readings.
How would you check for swimming for something like that?
I have no idea. Ashley?
Good question. I don't know if I've ever seen anyone. I think Mike actually might be the better one to discuss this topic. I'm only familiar with like running and cycling threshold tests. I've never seen or performed a swimming threshold.
I think because swimming is essentially I'll say it's what you want to have is that flat curve, because if you have the flat curve going out as far as possible, you're going to be able to hold on to the higher speed. If you increase your swim speed just the slightest amount, it takes a lot more effort. And that's a function of the amount of drag from the water itself. The amount of effort to get through water incrementally is significantly higher than getting through air. And so in the case of swimming, and this, just from experience and looking at swimmers themselves, they seem to be able to go at a very high level for a very long time, depending on the event, obviously. For triathletes, it's, they want that aerobic flat curve going out there as far as possible. For a sprinter, okay, now you're talking about, something that's probably more of a crit rider where, if they can sustain a very high power level for a short period of time, then, you know, they're going to be obviously faster. But if anybody has tried doing that swimming, I know that probably a couple weeks after a marathon, I got in the pool for the first time, and I swam 50 yards and I was exhausted. And it was because I was putting out so much effort to get through the water that I was not experiencing when I was in my aerobic condition while I was running. And over time, then I learned how to portion out my swim effort to get a decent speed, which is still slow for me, or for most people. But yet, last, the 30, 40 minutes that it took to do the event itself. So I guess that's probably the easiest way to do it is it takes a significant amount of effort to go any faster in the pool. So you want to have that aerobic base as strung out there as far as you can from a swimming standpoint, unless you're doing sprints.
I guess that'd be the same with power rowing, similar.
Rowing,
Yeah, power rowing.
competitive rowing, or
Yeah. Yeah.
competitive rowers have the highest anaerobic. That is the most anaerobic sport you can do. And that's been scientifically proven. And that probably explains why the Zwift world champion is a rower and not a cyclist.
Yeah, there's a really good video on the Olympic channel that they do like the anatomy of a such and such athlete, and they did one of a rower, an Olympic rower, and yeah, very anaerobic.
So Jim, this is Steve.
Yeah.
Just to make sure I understand how this applies, and say a long event, you're doing a century or a metric or whatever out on a bike. You want to ideally stay like high tempo or very low end of the threshold, but mostly high end zone 3, or what do you?
No, you want to, once again, think of that zone around the threshold as being gray.
Okay.
Okay, so you're not, let's go back to this curve. So like, for instance, in this one, if you're out there, slugging it out at, the DK, this person would definitely want to stay 220 or below, because at 220 or below, they're aerobic. Above 220, it starts getting gray.
Okay.
Yeah, it's pretty, that one's pretty straightforward.
Yeah, all the matches are to the right of 220.
All the matches are to the right of 220, and the flamethrower is to the right of 260 in this case. So I don't know if how many people on the call have seen what's Ashley, who's the guy who did that? Is Devin about Trainer Road?
Oh, Dylan Johnson.
Dylan Johnson. Okay. So I'm not going to comment on his presentation, but this is what he was trying to explain, is that, let me go back up to this curve where we got the 2 lines. Okay, there you go. Whoop. So this is what he was trying to explain during that video, is the green line and everything to the left of that, that's aerobic. The yellow line and everything to the right of that is anaerobic. And then, you know, the point he was trying to make is if you spend too much time in this gray area, it's not the most optimal training. So that's, yeah, I mean, what he was referring to, he was literally referring to a lactate curve in his presentation.
And I might add that that's also the case for marathon training. Most marathon training will be either very low effort, well aerobic versus say, 15 to, maybe 20% of your time at the higher end of that curve, but not so high that you would go anaerobic. The duration would be cut short before you went anaerobic, so that you don't shut that down. And in a lot of cases, we don't actually train at marathon pacing until a week or two before the marathon, and that's only to get used to or get a feel for the pace itself. It's not really necessarily to improve your fitness as much as it is to have you be familiar with that pace and recognize it for your race. But the two engines that you want to work on are more so the aerobic with some anaerobic in order to just kind of beef up the engine a little bit.
And I wanted to add something to that, is that so depending on what energy system you're trying to work, you're going to experience these adaptations. So with like an aerobic ride, so like say you're doing all these like just long endurance rides, you're going to have a lot of great adaptations that are associated with that. So like increase in capillary density. So that means more capillaries are getting to the working muscle. You're able to bring in glucose, take all the metabolic waste, bring it out. And so you're getting that more circulation, you're getting more mitochondria within the muscle. And so your cells or your muscle cells are able to produce more energy, more ATP for you. And so if your event is a long aerobic event, you need to make sure you're training that energy system that also has the different characteristics that are seen with that training. So like say if you're doing a lot of high intensity, I mean, high intensity is fun and everything, but you're not going to see like the increase in mitochondria, increase in capillary density, increase in lung capacity, like all these different things. And so that's why you really want to make sure that you're targeting your training for your event, the requirements needed for your discipline or event.